All right, this question asks us to write formulas for the following four compounds. So in order to do nomenclature correctly, you have to be able to go from formulas to names and from names to formulas. And so this one is names to formulas in its practice. So we start out with lithium oxide. But in order to figure out the correct formula, you must first know the species that we're talking about. Well, lithium is a metal, oxygen is a nonmetal, so put together a nonmetal and a metal, that means it's an ionic compound, and it's made from ions. Because you know that it's made from ions, now we can start to write down the formula because we can know the ions that the compound lithium oxide is made from. It's made from the lithium ion, and we would go to the periodic table to look at that in group 1 to figure out that it's a +1 ion. And the same thing with oxygen. We know that it's a monatomic ion because oxygen becomes oxide. And so we would go to the periodic table to figure out what the charge on that monatomic ion is. It's in group 16, so it's 2 minus. So in order to put together a formula for an ionic compound, the goal is that the formula has to be neutral. So how many lithiums, how many 1+ ions do I need in order to balance out a 2- ion? Well, I need 2 of them because for every lithium, I get a 1+ ion, and I got to get to 2+ in order to balance out the 2-. So I get lithium 2O. And if you are into sort of a game in order to figure out what the formula is, a lot of times it can help to look at these charges. If you notice that the charge becomes the suffix, or becomes the subscript in the formula. Now, this doesn't work this way every single time, but it can help you figure out how many of them that you need in order to come up with an overall neutral compound. So let's try sodium chloride. So it's Li2O for lithium oxide. For sodium nitride, I have sodium ion, group 1, and nitride in 3- for group 3. So how many do I need? I need 3 sodiums for every 1 nitride. Again, these charges helping you to figure out what those subscripts might be. Okay, barium phosphide. Barium is group 2, so it's 2+, and phosphide is group 15, so it's 3-. So putting that together, in order to get a common neutral compound, I'm going to have to figure out what's the least common multiple between 2 and 3. And the least common multiple is 6. So what do I multiply 2 by in order to become 6? 3. And the same thing with the phosphide. What do I multiply 3 by in order to become 6? And so I get 2. And so again, if we take a look at these charges, we see that the charges have helped us determine what are the subscripts in the formula for barium phosphide. Now, this particular exercise can be a little bit deceiving at first. In some instances, it won't actually always be equal. So in this example, magnesium ion is Mg2+, sulfide is S2-. You only need 1 of each in order for them to cancel. So these charges do help us determine what the subscripts are in writing the formula, but we don't do that blindly. We have to remember that the ultimate goal of figuring out what the formula for an ionic compound is to write a formula that represents a combination of ions that's neutral. Magnesium being 2+ and sulfide being 2-, 1 and 1 of each makes it neutral, so I don't need any more of them. And in every other case, I wrote the numbers down that I did because that's the ratio of ions that gets me to a neutral compound. Okay, thanks.